Good morning. I'm back in front of this computer. So today I'm going to show you how to do Article 2 for your Newsela assignment. And I have a little cheat sheet to help you with your annotation. So I'm going to read through the article. I'm going to share my screen. I already have it open because I figure at this point, you all should know how to log in. So I'm not going to go through the login process. We're going to just get right into it. Okay, and I have another sheet. I don't know if I can do this. I don't know if I can split my screen, but I want to share this other new tool that I have for you. And you will find this in your toolkit. And it's going to help you with annotating. Okay. All right, so I want to share this and then I'll be going back and forth. So here, when you do an annotation, you can use vocabulary in purple. You see that? I want to put this in your attachments. So any new unfamiliar words, any slang words or jargon. Jargon is another term for slang. Abbreviations or acronyms, those things you will highlight in purple. If you want to make a connection, and you all know those connections. What are the three connections? Well, the connections we talk about the most. Text to, text to, text to. And you can also use text to media. That's another one because it's kind of popular. We use a lot of videos and things like that. In green, okay? And red, questions. If you ask questions in the box, this will help me out a lot because I am reading what you write and I want to go back into that text and I want to respond to you. So give me some questions, please, okay? Important parts. Highlight the main ideas of the article, important details. So main idea and important details. That's what we're going to use the yellow for, okay? So you can make a little note for yourself if you can't print this out, but this is what I'm going to use as I'm going through this text. So I'm going to change my share. I have a new share. We'll go back to the article, okay? Now, once again, I don't think this is going to work, but you'll see the word max. So I have it on max. However, let's say you're not, I know I can't read on the max level. Just drop right down to 750 or to the next level. If you're someone who's usually scored very well on most state tests and even classroom tests, I would just go down one level. But if you're someone who's always struggled, you can start here and work your way up, or you can start down and work your way down. Either way, you can change the level of the reading text, all right? But I'm gonna click max, because I want to be changed. All right. Time travel, okay, so here let's see the title, assignment, this is your assignment here, and you also have these two questions. Time travel simulation resolves grandfather paradox. Paradox. Can I highlight this part? Because I really want to know what this is about. That's a question. Well, maybe I can only do it when I get into the text. So I'll keep going. Visitors explore an imaginary time machine. You know, one of those good things to do is actually look at just the images. So I have an image here. Do I have any more images? No, probably because it's the max. I don't know, they only gave me one. So I only have one caption to read right here. Visitors explore an imaginary time machine, part of the Philadelphia International Festival of the Arts. At the Kimmel Center for the Performing Arts, March 28, 2013 in Philadelphia. AP, that stands for the Associated Press. Photo Matt Rourke by Lee Billings, Scientific American, 1330. So this was published in 2014. Now remember the article we read yesterday kind of talked about what it means to time travel and the two different opinions. So we have the science fiction viewpoint and as well as the scientist viewpoint. On June 28, 2009, the world famous physicist Stephen Hawking threw a party at the University of Cambridge. I'm going to highlight that Stephen Hawking because not the whole thing. I just want Stephen Hawking. And since I'm going to make it green because that is a text-to-text connection. I Remember, in the thrill of time travel, Stephen Hawking was the scientist who did not believe in time travel. I remember that from yesterday when I read that article. So I'm making that connection to just the same article that from yesterday. So on June 28th, the world famous physicist Stephen Hawking I'm rereading A Party at the University of Cambridge, complete with balloons, hors d'oeuvres, and iced champagne. What is that all about? Everyone was invited, but no one showed up. I'm gonna save that, because now I have a question. Everyone was invited, but no one showed up. And since I have a question, I'm gonna put that in red. And let's see, so everyone was invited, but no one showed up. Why did he have a party? Why didn't anybody, that's my question, why didn't anyone show up for his party? I would feel terrible if that were me. Hawking had expected as much because he only sent out invitations after his party had concluded. It was, he said, a welcome reception for future time travelers. A tongue-in-cheek experiment to reinforce his 1992 conjecture that travel into the past is effectively impossible. Oh my goodness. Hold on one second. I gotta kind of reread this. Hawking had expected as much because he had sent invitations out after his party had concluded. This guy is a trip. It was, he said, a welcome reception for future time travelers, a tongue-in-cheek experiment. I'm going to highlight that tongue-in-cheek because it's written in purple, and I'm going to put that in purple because that's for my vocabulary. And I've heard that phrase tongue-in-cheek. So it's kind of a phrase that is kind of like a snarky comment or a little bit, I want to say facetious. And you know what I can also do, because we're at the power of the internet and you're doing this at home. So I'm going to tell you, I'm going to change my screen. I'm going to open up a new tab and I'm going to change my share. And you know what? I'm going to actually see. I'm going to go look it up right here. Tongue in cheek. Without really meaning what one is saying or writing. I like my idea better. Flippant. Yeah. Smart alecky. Yeah. Look at all these other ones. Humorously. So I'm going to add that in there too. Go back to my other clip. So that's what I wrote. Phrases that, a phrase that is kind of like a snarky comment or a little facetious or kind of sarcastic. He knew no one's going to show up because he did this for future time travelers. An experiment to reinforce his 1992 conjecture. Conjecture is, I want to even, this one I can look at as vocabulary, but I am actually making a text-to-text connection from yesterday. In the thrill of time travel, Hawking posed the idea or theory that time travel doesn't exist or can't happen. Time travel can't happen. So I'm sorry, but for me to spend that much money on a joke, that's nasty. So his 1992 conjecture that travel into the past is effectively impossible. But Hawking may be on the wrong side of history. Interesting. Recent experiments offer tentative support for time travel's feasibility, at least from a mathematical perspective. The study cuts to the core of our, so wait a minute. Hawking may be on the wrong side of history. So I just want to put, to me, this is a detail because it's kind of like showing, I would say, they're comparing and contrasting a little bit or kind of offering a different opinion, a different claim about time travel. Recent experiments offer tentative support for time travel's feasibility. So people are actually, some scientists are trying to experiment with time travel. I wonder how many grants they can give for that, at least from a mathematical perspective. The study cuts to the core of our understanding of the universe and the resolution of the possibility of time travel. Far from being a topic worthy only of science fiction, would have profound implications for fundamental physics as well as for practical applications such as quantum cryptography and computing. Okay, so we have some serious vocabulary in here. I'm gonna put a highlight here by quantum and cryptography, because those are some vocabulary words I can make a text connection to quantum because there was a show when I was growing up called Quantum Leap, and it was a time travel show. So the main character would go to these different points in time, and it was always some type of crime that was going on. And he would have to kind of figure out, why is this person here? What happened to the person? How could he solve the problem? But he could still not involve himself in the actual solving of the problem. So we are dealing with physics, quantum cryptography, and computing. I'm going to leave those vocabulary words there because I'm hoping, since this is the introduction paragraph, that those things will be clarified later on in the text. I'm going to keep this video short. That's about it in terms of annotating the text. And I hope you can, hope this helps you out, because I want you all to really start using these features. So just quick review. In the first part, I highlighted the green because I made a text-to-text connection from the previous lesson to this lesson about Stephen Hawking. Then I asked a question. Why didn't anyone show up for his party? Because I was wondering, why would somebody buy balloons, hors d'oeuvres, and iced champagne, and then nobody show up? I thought that was rude at first, but then I realized Stephen Hawking, he made a tongue-in-cheek, he did this as a tongue-in-cheek, like a little snarky comment. He knew no one was going to show up because he sent the invitations after. So he's kind of saying, hey, time travelers, if you're really going to do it, you're going to go back in time and come back, and then you'll be at the party. So we'll see what happens. Wouldn't that be something if that really happened? And it was another way for him going back into his 1992 conjecture. I added conjecture because I know that the conjecture that they're referencing is from the first article that talks about how Stephen Hawking did not approve of time travel. So then I have a yellow connection or important detail. So this one to me is a detail because it's saying that it's questioning, is Stephen Hawking wrong? And there are some scientists who are still trying to use math to solve the problem. A lot of times kids always ask, well, I need this. It's showing you right now, scientists are still trying to use math to figure out if we can go into time travel. So if you're interested in that type of thing, I would definitely pay attention to my math lessons. And then I did one more highlighting of quantum and cryptography, because I hope that further on in this article, they're going to explain those things to me. And maybe I can actually add that as a question too. I'm going to add this whole part, even though I have this as my highlight. I'm going to put, I wonder if the article will explain more about quantum cryptography. And that word cryptography is telling me a lot too. So I have some ideas, and my main idea is knowing that graph usually evolves writing, and crypt. When I heard of crypt, it's like something like in the past, like something that's dead. So this is just my current thinking on the topic, and I'm hoping that later on through the article, it will clarify my understanding. So I want to stop my share. I hope this video was a little bit better because it's not as long, and you can take it and use that to help you. All right. Take care, everybody. See you later. Hope to see you at my online session, my Google Hangout later on this afternoon. Bye.